Hey everybody, this is Mrs. Costello. One more time this semester, we're going to do some decay functions today. So Mrs. Roby did the growth functions. I'm going to do the decay, which honestly, I'm just kind of doing the opposite of what she's doing. So a function is going to be a decay function. So let's put that in the first blank, decay. If the base is, I'm going to put in here less than 1. Yes, that usually means it's a fraction. So if you want to put that underneath too, that is fine. But we also need to be a little bit careful too, okay? So this means if we are decaying, remember yesterday we went up, we grew. That means it is going to fall from left to right or decrease from left to right. That is fine too. Either way. All right, so let's talk about this parent function. So for our parent function, we are going to use b. Our base is going to be 1/3. Okay, so let's plug in the easy one. So let's plug in, so b to the power of x. We'll start with 0. So y equals 1/3 to the 0. Well, remember from the video yesterday, anything to the power of 0 is just 1. So in the 0 box, we're going to put a 1 for that y. Awesome. And then let's go ahead and do the same thing. Y equals 1/3 to the first, which is just, guess what? 1/3. All right. And we could keep going with those positives, like y equals 1/3 squared, which means 1/3 times 1/3. 1/3 times 1/3 is 1/9, so that goes in the second box, okay? And our last box, if we really wanted to do 1/3 times itself 3 times, think about that as like 3 cubed, so y equals 1/3 cubed. I should have parentheses on literally all these, sorry guys. So 1/3 times 1/3 times 1/3, that is going to give me 1/27. Wow, okay. All right, now, hopefully Mrs. Roby yesterday talked about when you have those negative exponents, you don't actually make negative numbers, you flip your number, right? You flip it. So let's talk about y equals 1/3 to the -1. It would stay the same, but we would flip it. So when we flip it, it's going to become 3/1. All right, see how this one and this one are opposites? Guess what? The rest of them are going to be opposites too. So if 2 was 1/9, we're just going to flip it for -2. So that's going to be 9/1, which is just 9. And same thing for the 3 and the -3. Let's flip that guy. So 27/1, which is just 27. So if we're going off of our table, on our graph, let's just plot like these guys right here, the -1, the 0, and the 1, okay? So if I go to -1, oops, that's a little too, okay, -1 is at 3. So -1, 1, 2, 3, cool. 0 and +1 right there. And then 1 and 1/3. I'm not going to be super picky on where your dot is as long as it does not go on a corner. And we make our little shape right here. Okay, perfect. So notice our graph from left to right, it should decrease, right? So it should fall. The graph falls. That's what we use for these guys, from left to right. The x-axis, yesterday the x-axis was an asymptote. Guess what? It is still an asymptote. I call it a boundary, but it is still an asymptote of the graph. The domain of the parent function is, hopefully Mrs. Roby went over this, it is all real numbers. That is an easy point. And then our range. Well, let's look at our y's. What are they doing? They are above that x-axis, which means they're getting bigger. So I'm going to put that y is greater than, and then it's always going to be above that asymptote, which is 0. Okay, so It's very, very, very similar to yesterday, except this time, you know, we're changing some things around. Graph the following functions and then state the domain and range. So number 1 is very, very, very similar to our last one. So we're going to use -1, 0, and 1 for our points. So -1, remember we flipped that guy. So instead of 1 over 2, it is going to be 2 over 1. So we'll just put a 2 right there. Anything to the power of 0 is 1. So 0, 1 would be our next point. And then our to the power of 1, that just means it stays the same, right? Kind of backwards from yesterday. Excellent. So I like to, and I don't know if Mrs. Roby did this, but I like to actually kind of like draw in the asymptote. I make a little squiggly line. My asymptote, because there was no up or down movement, it's just going to still stay at 0. So if you want to draw a little squiggly, because that's your boundary, do it. I like doing that. You can do it if you want to, but you don't have to. So -1, 2, -1, up to 2. 0, 1 is right there. And 1 and 1/2 is like right there. And we'll draw our shape and we'll just make sure we don't hit that asymptote at all. Awesome. Our domain is our easy point. That is all real numbers. The range, okay, well, I'm above with the big Y, so I'm going to make Y is greater than, and my asymptote is 0, so I'm just going to be at Y is greater than 0. All right, number 2. Ooh, we got some movement in here. So remember that up here with the X, this moves your graph left or right. Remember, it's a little opposite of what we normally think. So instead of -2, we're not going to go to the left with the negatives. We are going to go right 2. And this -1, this is my down 1. Okay. Now, I like to, again, this is, you know, my personal preference. I like to make our new, like, axes. So what I do is I actually go right 2 and down 1. And I go, here is my new axis, right? This is my new center. So I'm no longer starting here where the green dot is. I am starting where the blue plus sign is. This is -1, 0, and 1, okay, for those X's. So my base is 1/4. So I'm going to make my points with 1/4. So 1/4 to -1, let's flip it. So it's going to be 4 over 1, or just 4. 1/4 to the 0 is 1. 1/4 to 0 is 1, sorry. And then 1/4 to the 1 is just 1/4. So when I start, I'm going to start at the -1, where I have my new thing. And sometimes I see people draw like all the lines in. If it really, really helps you, like draw all the axes in, then do that. That is totally fine. Okay, I'm going to draw on my squiggly asymptote though, because my asymptote is always where I move up or down. So, okay, let's do our first point. So -1 is right here, and then I'm going to go up to 4. 1, 2, 3, 4. Awesome. 0 and 1 is right here. I should erase the old green dots. There we go. And then 1 and 1/4 is right there. Ooh, and this is a narrow one. There we go. All right. Domain is my easy point. That is some all real numbers, and the range still matches the K. So Y is greater than -1. Same thing with 3. So on 3, we do have a fraction still, but it's still like a decay. And that's because it's smaller than 1, right? 3 over 5, that is absolutely going to be smaller than 1. So there is no movement. This one's not going to be that bad. So when we do our -1, we flip it. So instead of 3 over 5, it is going to be 5 over 3. To the power of 0 is just 1, and 3/5 to the power of 1 is still 3/5. Awesome. Now, No movement, so my asymptote just stays right here on the x-axis. And let's put those dots in. Well, 5 over 3, 5 is bigger than 3. So I know it's just going to be like a little bit over 1. So -1 up to 1, just go a little bit over, not quite at 2, right? Same thing, 0 and 1 right here, and 1 and 3 over 5. Okay, this guy is pretty compressed. The last one was really steep. This one's really compressed, or like really flattened out, and that's okay. Our domain is all real numbers, and our range is y is greater than 0 because that asymptote is going to be at 0. Cool. Hopefully we're getting the hang of this. Number 4. So we have to be really careful. Look at our base. Our base is 8 over 3. Is 8 over 3 smaller than 1? It's definitely not, because if you do 8 divided by 3, pretty sure you get like 2.66 repeating. So this is why I said you have to be really careful on that base. Don't always assume because it's a fraction, it's a decay. This is actually going to be a growth because it's bigger than 1. So we're still going to approach it the same exact way. Are we moving anywhere on our HK? No, we are not. So our asymptote is just going to stay on that x-axis. There's no moving up, down, left, right, none of that. Okay, 8 over 3 to the power of -1. Well, that just means we flip. So instead of 8 over 3, it is 3 over 8. 8 over 3 to the power of 0. Well, anything to the power of 0 is 1. And then 8 over 3 to the power of 1 is just 8 over 3. Excellent. So it is going to be a growth. We are getting bigger when we go left to right. We are getting bigger. So -1 and 3 over 8. 3 over 8 is a fraction. So as long as it's just not on 1, we good. 0 and 1 is right here. And then 1 and 8 over 3, we already said it's not quite 3. So as long as it's just under 3, that would be awesome. And it's a steep one. Right, our domain, all real numbers. And then our range is going to be y is greater than 0 because it's above that x-axis with the big y's, and we cannot touch 0. Ooh, number 5, we're stepping it up a little bit. We have a 2 in the front. We'll talk about what to do with that 2 in just a second. So let's think about this. Are we moving anywhere? No, we are not. There is no h or k in this, so that means my asymptote gets to stay right here on the x-axis. Nice. All right, 1/2 is my base. We've done 1/2 before. If we raise that to a -1, we flip it. So flip it 2 over 1, which is 2. And then 1/2 to the power of 0. Well, anything to the power of 0 is 1. And then 1/2 to the power of 1, that is 1/2. Perfect. Okay, now here's what we have to do with this 2. The 2 is a vertical stretch. So what we have to do is we have to take all the values we just found, the 2, the 1, and the 1/2, and we have to times it by 2. Let's do some space pen for this. Times 2, times 2, times 2. So our new y's, or our new points, are still going to be at -1, but 2 times 2 is 4. 0, and then 1 times 2 is 2. And then 1, and then 1/2 times 2 is just 1. So those are all my points that I'm going to graph on my graph. Okay, so -1, 4, 1, 2, 3, 4, cool. 0 and 2, right here. And 1, 1 is right there. And that's a steep one. I know we've been doing a couple flat ones, but that's a steep one. Excellent. Domain, all real numbers. The y's are on top, so they're going to be greater than. So y is greater than, and then they're above the x-axis, so it would just be 0 for that y. All right, I believe this is our last one. Ooh, and we've got a bunch of stuff going on. We've got some movement. So up here we've got a +1. So we are not going to go +1 to the positives. We're going to go to the -1. So this is left 1. And we've got a -3 right here. So that means down 3. So left 1, down 1, 2, 3. Okay, this is my new place. Again, if you want to extend that, like you want to make a totally new center like I'm doing right here, you do that. Okay, you can make it a different color if you want. You know I like colors, so let's do it. Okay, so my base is 2/3. So for that negative, remember we flip. So instead of 2/3, it is now going to be 3/2. It's rainbow pen time. It's the last one. Last time for rainbow pen. Plug in a 0. So 2/3 to the 0 is just 1. And 2/3 to the first is 2/3. Sweet. Ooh, sorry, you can't really see the 3. Ooh, even worse. Space pen it is. Oh, there we go. Beautiful. Okay, so 3/2 is just 1.5. So at -1, the new -1, remember, -1's right here, 0 and 1. -1, up 1.5 right there. Okay, 0 and 1 right here, and 1 and 2/3 right there. And there we go. Okay, domain, all real numbers. Our range, let's look at our asymptote. Ooh, I did not put it in. I apologize. Squiggly line. Well, I had to go down 3, so that means that my range, everything is still above. So we're going to do y is greater than still. And then everything is above -3, so we're going to put -3 right there. All right, everybody, that is all I have for you today. If you have any questions, feel free to ask your teacher tomorrow in class. Otherwise, enjoy the rest of your day.